Engines come in all shapes and designs. But did you know that the shape of the engine's cylinder can completely change how it performs? Whether an engine delivers raw power or strong pulling torque actually depends on one simple relationship: the bore and stroke. In this video, we'll break down everything you need to know about square, oversquare, and undersquare engines and understand how this design choice affects performance, speed, and efficiency. So let's dive right in. Before we talk about square or non-square engines, let's understand two fundamental terms: bore and stroke. The bore is the diameter of the engine cylinder, and the stroke is the distance the piston travels up and down inside that cylinder. Together, bore and stroke determine the engine's displacement, which is the total volume of air and fuel it can burn in one cycle. But more importantly, their ratio determines how the engine behaves, whether it's built for high-speed performance or low-end pulling power. What is a square engine? A square engine is one where the bore and stroke are equal or nearly equal. For example, if an engine has an 80 millimeters bore and an 80 millimeter stroke, that's a square engine. This type of design gives a balanced performance, good power at high RPMs, and decent torque at low RPMs. It doesn't push too far in either direction, which makes it an excellent all-rounder for daily driving or general-purpose machines. Because the piston doesn't travel too far or too short a distance, the internal stress and friction are moderate. That means smooth operation, reliability, and longer engine life. You'll find square engines in many modern cars and motorcycles, where manufacturers want both decent acceleration and good fuel economy. What is a non-square engine? Now, when the bore and stroke are not equal, we call it a non-square engine. These engines come in two varieties: oversquare and undersquare. Let's explore each in depth. In an oversquare engine, the bore is larger than the stroke. This means the piston doesn't have to travel a long distance during each revolution. Because of that, it can rev higher and produce more power at high RPMs. That's why most sports cars and superbikes use oversquare engines. They're designed for speed and performance. Oversquare engines offer several key advantages that make them ideal for high-performance applications. Because their bore is larger than the stroke, they can reach much higher RPMs, which allows them to produce greater horsepower. The shorter piston travel also reduces frictional losses inside the cylinder, leading to smoother and more efficient operation at high speeds. Additionally, the wider bore provides more surface area for effective cooling and enables larger valves, allowing better airflow into and out of the combustion chamber. As a result, oversquare engines deliver superior high-speed performance, improved cooling efficiency, and smoother operation, making them a popular choice in sports cars, racing motorcycles, and performance-oriented vehicles. Despite their performance benefits, oversquare engines also have some notable disadvantages. Because of their shorter stroke, they tend to produce lower torque at low RPMs, which means they lack strong pulling power during slow-speed driving or when starting from a stop. This makes them less suitable for vehicles that need to carry heavy loads, tow trailers, or climb steep inclines, as these situations require more low-end torque. In short, while oversquare engines excel at delivering high-speed power and smooth performance, they are not ideal for applications that demand strong torque and heavy-duty capability. Next, we have undersquare engines, also called long-stroke engines. Here, the stroke is longer than the bore, meaning the piston travels a greater distance each time it moves up and down. This design increases the leverage on the crankshaft, resulting in more torque, that twisting force you feel when a vehicle pulls hard, even at low speeds. That's why you'll find undersquare engines in trucks, SUVs, tractors, and cruiser bikes, machines that need pulling strength rather than top speed. Undersquare engines come with several distinct advantages that make them highly effective for heavy-duty and utility applications. Their longer stroke allows the piston to travel a greater distance, generating stronger leverage on the crankshaft, which results in higher low-end torque. This gives the engine excellent pulling power at lower RPMs, making it easier to move heavy vehicles or climb steep hills without needing to rev high. Additionally, because these engines operate efficiently at lower speeds, They often deliver better fuel economy during city driving or when hauling loads. Thanks to this strong torque and efficiency combination, Undersquare engines are ideal for heavy loads, uphill driving, and vehicles designed for durability and consistent performance rather than high-speed operation. Undersquare engines also have a few disadvantages that limit their performance potential. Because of their longer stroke, the piston must travel a greater distance with each revolution, which naturally restricts the maximum RPM the engine can reach. This makes them less suitable for high-speed performance or racing applications. The extended piston movement also causes higher internal friction, as there's more contact between moving parts, which can slightly reduce efficiency and responsiveness. Over time, this increased motion can lead to more wear and tear on components, such as the piston rings, cylinder walls, and connecting rods. As a result, while undersquare engines excel in torque and efficiency at low speeds, they sacrifice top-end performance, smoothness at high RPMs, and long-term durability under heavy stress. Now that we understand square, oversquare, and undersquare engines, let's take a moment to talk about what really defines them: the bore-stroke ratio. The bore-stroke ratio is simply the bore divided by the stroke. This one number tells us a lot about how an engine will perform, whether it's built for speed, balance, or pulling strength. Let's break it down. When the bore and stroke are equal, the ratio comes out to about 1, and we call this a square engine. For example, if an engine has an 80mm bore and an 80mm stroke, that's 80 divided by 80 equal to 1. Next, when the bore is larger than the stroke, the ratio goes above 1, and we call this an oversquare engine. Take a 100mm bore and a 60mm stroke. 100 divided by 60 gives a ratio of 1.67. That's clearly an oversquare design. Finally, we have the opposite case, when the stroke is longer than the bore. Here, the ratio falls below 1, and we call this an undersquare engine. For instance, a 73mm bore with an 86mm stroke gives a ratio of 0.85. That's an undersquare engine. What's the best engine type? Well, it depends on your needs. If you love speed and quick revs, an oversquare engine is your dream. If you value torque, durability, and fuel economy, undersquare is ideal. And if you want the best of both worlds, square engines give you that perfect middle ground. Every design has its purpose, and understanding this helps you appreciate the engineering behind every vehicle, from superbikes to heavy trucks. Thanks for watching. If you found this breakdown helpful, don't forget to like, subscribe, and share this video.